Okay, so we've determined if everything is done accurately here, and with all the reasoning that comes down to the most fundamental level of what's going on here, which is that you're transferring charge across this capacitor. At the most fundamental level, we conclude that we can get the rate of change of the voltage, because if we do this calculation, okay, we get 7.5 volts per second times delta T, which means that 7.5 volts per second is the instantaneous rate of change of the voltage. Now that is going to change the voltage of the capacitor, which probably almost certainly change the current through the capacitor. So in another finite delta T, you're going to have a change in the rate, okay? And that's exactly what you expect, because you know that in general this is going to be solved by a differential equation, okay? Well, question now is, what effect is this going to have on the rate? Let's assume that the source voltage doesn't change a whole lot. So what's going to happen in the next short interval? Is it going to, you're going to have more voltage change or less? Okay? And, you know, with my solution or with your solution. And then what happens if we reverse this? Okay? The signs of these things, the directions of these voltages and so forth, all affect the question, the answer to the question whether the rate of change of current is going to be positive or negative, and whether it's going to change in a positive or negative sense as time goes on.